extension 3 in Module 1, and this extension deals mainly with changes in velocity, or as we've learned now, acceleration. And in fact, Ranking Task 1 asks us to rank these according to the acceleration. Remember that acceleration is a vector quantity. It can be both negative and positive. We're going to rank the negatives lower than 0 or any of the positive accelerations. So how do you figure this out? Again, acceleration is a change in velocity over a change in time. It turns out that the time interval, all these cars, all these wagons are changing velocity. And of course, that occurs over time. The time, notice, is all 1 second. So really, our acceleration equation, which is acceleration equals change in velocity. We're actually going to write it final velocity, VF, minus VI or V0, whichever one you want. So it's the change in velocity divided by the change in time. Well, in this case, the change in time is 1 second. So really, what this one comes down to is the change in velocity. The change in velocity is going to be equivalent to our acceleration because we're dividing by 1. So now we can take a look at these carts and we realize, okay, in fact I'm going to write this as V0. V initial is V0 because that's the way it's written here in all these scenarios, V0. So in situation A, your cart initially was going at positive 5 meters per second. It winds up going positive 10 meters per second. Therefore the difference is 5 meters per second. In fact, the units here are 5 meters per second. That's the change in velocity divided by the time, of course, which is 1 second. So it's 5 meters per second is the acceleration. In B, same situation. My final velocity is 20. My initial velocity was positive 15. The difference, again, 5. In C, notice that here I started out going at positive 15. I wound up at 0. So my final velocity was 0 minus my initial velocity, which was positive 15. Therefore, the difference is negative 15. So that's actually a negative acceleration. In D, notice that I start out going at negative 25 and I wind up going negative 10. Here the math, you have to be very careful with the math here. But you take your final velocity, which is negative 10, notice because it's going to the left, negative 10, I'm going to write it out in fact, negative 10 minus my initial velocity, which was, notice, negative 25. And when you do the math, negative 10 minus a minus 25 is really like negative 10 plus 25, so therefore you wind up with plus 15 as your acceleration. Notice in E, I started out going 25 meters per second. I wound up going 25 meters per second. No change in velocity, therefore no acceleration. And finally in F, I start out going at positive 25. I wind up going at negative 10. So again, watch your math. You take your final velocity, negative 10, minus your initial velocity, which in this case was positive 25. So therefore, minus 10 minus 25 is negative 35. That's a big change. Not only did the cart slow down, it actually changed direction, started going back the other way. So if I'm going to rank these, I rank the most negative as my least, and therefore that's going to be situation F. Negative 35. What's next? C is a negative 15. E is 0, so I'm going to write E. Then notice that A and B are both tied at 5, positive 5. And then finally, my largest acceleration is going to be in D, because that was a positive 15. And there you have it. That's the first ranking task. Okay, moving on. Ranking task 2. Now we're asked to find out the final velocity of the wagon. Notice what we've been given. We've been given the initial velocity. We've been given the rate of acceleration, the rate at which the velocity is changing. And we want to know the final velocity after 1 second has passed. So there is an equation that will handle this. It's final velocity, VF, equals initial velocity, plus the acceleration times time. You can use the equation, but for me it's almost better to either use your hand speedometer or just think about this in your head. So if you imagine in A, my initial velocity is 3 meters per second positive, and I'm going to accelerate at a rate of 5 meters per second every second for 1 second. So that means in 1 second I'm going to add 5 meters per second to my speed, given the fact that I start out at 3. So what's 3 plus 5? 8. So in 1 second my speed is going to change to 8 meters per second in A. In B, I start out at 10 meters per second. My acceleration is negative. So my velocity is a positive, my acceleration is negative. That means I've got to be slowing down. I start out at 10, but then I add negative 2 meters per second to my speed, or to my velocity, which means that after 1 second I'll be also going 8. B. In C, notice that I'm starting out at negative 4. I'm moving to the left, and my acceleration is positive 3. So I need to add 3 meters per second to my velocity in 1 second. So I start out at negative 4, but I add 3 meters per second. So I wind up at negative 1 after 1 second. In D, I start out at negative 6, because again I'm going to the left. Notice there my acceleration is also negative. So to that negative 6 I need to add another negative value. So therefore negative 6 minus 4 is going to wind up being negative 10. In E, I start out at positive 4, and my acceleration is also positive 4. It's a positive acceleration. So to my 4 meters per second of velocity, I'm going to add an additional 4 meters per second in 1 second. So therefore my total is 8 after 1 second. I speed up in the positive direction. And finally in F, I'm going at positive 10. My acceleration is negative 10. So I have to take away 10 meters per second of speed in 1 second, and therefore my velocity winds up being 0. So if I'm going to rank them from least to greatest, again, velocities do have both positive and negative values. I'm going to rank the negatives first. So therefore D is my least at negative 10. C is my next least at negative 1. F is at 0. Now I've got a tie between A and D and E. Oops. I'm writing my numbers, not my... That should be a C there, and this one should be an F. And then finally, oops, A and B and E, my mistake. And now we've accounted for everything. Okay, moving on. Ranking task 3. Now what they want us to do in this one, if we read the instructions, is we want to figure out the time between my initial velocity and my final velocity if the acceleration, the magnitude of the acceleration, is the same. Now some accelerations can be positive and some can be negative, but the actual value, the magnitude, is going to be the same. And so therefore the question is, how long would it take to accomplish the change that is indicated? So for example in A, I initially was going at 5 meters per second. I wound up at 10 meters per second. And so let's say that the acceleration was positive 5 meters per second. That would mean that it would only take 1 second to accomplish that change if my acceleration is positive 5 meters per second. In B, notice it's the same thing. I'm going at 15 and then I wind up at 20. Again, the magnitude of the acceleration has got to be the same as in A, 5 meters per second per second. So therefore it would only take 1 second to change my velocity by 5 meters per second. In C, I start out going at 15 meters per second. I wind up at 0 velocity. Remember, my magnitude must be the same as both in A and B, 5 meters per second per second. In fact, since I'm slowing down here, it's got to be a negative 5 meters per second per second. So how long would it take to go from 15 to 0 if you're losing 5 meters per second every second? It's going to take 3 seconds. You're going to go from 15 down to 10, then 10 down to 5, and 5 down to 0. Now notice in D, we're moving to the left. We start out going at negative 25. We wind up going at negative 10. Again, the magnitude must be 5 meters per second. And in fact, since I am slowing down while I'm going to the left, my acceleration must be to the right, or positive. So my acceleration's got to be a positive 5. I start out at negative 25. To that I need to add 5 meters per second every second. So in the first second I'll go from negative 25 to negative 20. In the next second I'll go from negative 20 to negative 15. And then finally I'll go from negative 15 to negative 10, which is where I wind up. So therefore it takes me 3 seconds in D as well. In E, notice that I start out going at positive 25 meters per second, and I wind up going at positive 20 meters per second. I'm slowing down to the right. My acceleration, the magnitude must be 5. The direction, or the sign, is negative in this case. So negative 5 meters per second. How long does it take to go from 25 to 20? If my acceleration is negative 5 meters per second, it only takes 1 second. And finally in F, notice that this one undergoes a dramatic change. It goes from positive 25 to negative 10 meters per second in velocity. Again, the magnitude of the acceleration must be 5 meters per second. In fact, in this case, it's got to be a negative 5 meters per second. How long does it take? I start out at positive 25. It takes me 1 second to go to positive 20, another second to go to positive 15, another second to go to positive 10, another second to go to positive 5, another second to go to 0, another second to go to negative 5, and then finally another second to go to negative 10. It took me 7 seconds to accomplish the change. And therefore, in ranking these, I want to go from least to greatest. A, B, E, all the smallest at 1 second. Then C and D tied at 3. And then finally F took me the longest, 7 seconds. Moving on. Ranking task number 4. Now notice in ranking task number 4, we need to figure out the final velocity of the object. So what we have here is a motion diagram where I'm again seeing the position of an object at discrete moments in time. They only care about the final velocity. All these things are moving from left to right. All we care about is the final velocity. All we care about is the last 2 dots. Those are the last 2 the pieces of position information we have for this moving object. Now remember how to get velocity. Velocity is displacement over time. Now I don't know how long it is between each of these dots. They don't tell me. It could be 0.2 seconds, it could be a second. We know they're all uniform. So let's just call it a second to make life easy for ourselves. So therefore, to find velocity, average velocity, during that last time interval, we need to know displacement over time. And of course we said the time, we're just going to say that it's 1 second. And therefore all we care about is the displacement. Which one undergoes the greatest displacement, which one undergoes the smallest displacement. Notice that in A, my change in position is from 8 to 10, and therefore displacement is positive 2. In B, the displacement is positive 1. In C, the displacement is, about 3.5, maybe 3 3/4. 3.75. In D, the displacement is 3. In E, the displacement is about 0.5, it looks like. And in F, my displacement is 1. So to rank them, again, you go from the greatest displacement to the... And again, here the velocities are all positive because your motion is from left to right, so we don't have to worry about any negatives here. So you go from your smallest value to your largest value. So E would be the smallest. Looks like we've got a tie between B and F. Then D. Then C. Oops, I'm sorry, I missed an A. A should be in there. Then D, and then C. Okay. And then finally, ranking task number 5. Ranking task number 5 is actually simpler than it might appear. You might be intimidated because we're supposed to find out the average acceleration. And that might seem very, very daunting. The key to this one is to look at the dots and think about what we learned in doing all those iPad activities where we were rolling the ball across the desk or up a ramp or down a ramp. Notice in A, what do you notice about A? Do you see a bunch of dots that are evenly spaced? What kind of motion is associated with a motion diagram where your dots are evenly spaced? An object that's moving at a constant velocity. Remember that acceleration is change in velocity, final velocity minus initial velocity, divided by time. Notice in A, is your velocity changing? If it's not, then what happens up here? What happens to your numerator? Isn't it 0? An object that's moving at a constant velocity has an acceleration of 0. Notice that in B, yeah, the speed might be different, but isn't that object moving at a constant velocity? Was its final velocity the same as its initial velocity? You betcha. And therefore, 0. And so you can tell the objects that are moving at a constant velocity by the spacing of the dots. If the spacing is the same throughout the motion, you've got an object that's moving at a constant speed and therefore an acceleration of 0. So A, B, and D all have acceleration 0. What do you notice about situation C? Your dots are getting farther apart. The object is getting faster. What do you know about an object that's moving from left to right that is getting faster? It's got a positive acceleration. It's not moving at a constant speed, it's changing its speed. It is speeding up in the positive direction. It's got a positive acceleration. And finally in E and F, what do you notice? The dots are getting closer together. And therefore, what will we say about the motion? It's slowing down. In fact, since it's moving to the right and it's slowing down, we would say it's got a negative acceleration. And we can actually work out the numbers. I don't really care about that. All I care about is the sign. And by the sign, we can rank them. So right now, if I'm going to rank them, E and F, I'm going to rank them together. I'm going to assume that they've got the same actual value. I don't care about that. What's important is that by looking at these motion diagrams, you can instantly see that you've got negative acceleration in E and F. That'll be ranked first. Then A, B, and D would all be ranked together because they all have acceleration 0, constant speed. And finally C is the only object here that shows a positive acceleration because the dots are getting farther apart.